We are solving quadratic equations, and you can again look through all four of these methods. The first thing you want to make sure is that it's equal to 0, which it is. The first method we have listed here is square rooting. According to our sheet, square rooting only works when there is no linear bx term. So since we have a bx term, unfortunately we cannot use the square rooting method. The next method on our list is just factoring. Again, there's no order that you have to do them. It's just nice to do them in this order. Factoring says you should look for GCF first in the three terms. I do not see a GCF, so the next thing I would do is I would look at the quadratic trinomial, and I would look at the A and the C. A times C is 3. The only things that multiply to 3 are 1 and 3. Unfortunately, I cannot get them to add to 2. To multiply to a positive 3 and add to a 2. So factoring in this case will also not work. The next method on my list is graphing. Again, when you graph, you enter it exactly into your calculator as you have seen, or as it is written, making sure again that it equals 0, and it does. You hit your graph, and now when you notice this, again, every other time we've graphed, it's crossed the x-axis, and we were looking for the y being 0. Well, since here the y is not 0, the lowest one looks almost to be maybe a negative or a positive 1, and we may have learned that in our last chapter. So because no matter how hard we try, there's not going to be any zeros, and if I try to do a 0, second trace, 0, and I pick some left bound, and I pick a right bound, and then I guess, notice what happens on my calculator. It thinks, and it says no sign change because it never goes below. So graphing in this case also doesn't work. So my only option for solving this problem is to use the quadratic equation. So always write out your coefficients first. So A equals 3, B equals 2, and C equals 1, and then plug it into your formula. So here's the formula. Now plug in A, B, and C. Continue to simplify here. Continue to simplify further. So we get to here and we see that there's a negative under our radical sign. Again, whenever you see a negative under your radical sign, remember that you can pop that I value out, that imaginary number value, so it becomes plus or minus I square root of 8, all of that divided by 6. And now you should be able to reduce your radical of 8. Now, if you don't remember how, make your factor tree. 8 can be divided into 2 and 4. 4 can be divided into 2 and 2. So I have a pair of 2's, and I have a single 2. So now I have x equals, the negative 2 is still there, plus or minus, and because I had that pair of 2's, I have a 2, and then I have the I, and then staying under the single bar, or the square root bar, is the other 2, and all of that is divided by 6. Now, the last thing that we have to realize is that there are two terms in the numerator. There's the negative 2 term, and there's the complex BI term. And you should be able to simplify them if you notice, because I can pull out sort of a greatest common factor of a 2. So I'm going to actually do that, pull out a 2. So I get a negative 1 plus or minus, and then I'm going to leave this as an I, square root of 2, because I pulled the other 2 out, divided by 6. If I can pull out a greatest common factor out of my numerator, that allows me, or makes me realize, that I can simplify 2 and 6, so that I would be left with negative 1 plus or minus I square root of 2 over 3. So my final answer, through only using the quadratic formula, the other three methods did not give me a solution. The quadratic formula gave me an exact answer of negative 1 plus or minus I square root of 2, all of that divided by 3. And remember, we had to cancel out as we went through here.